Good evening to everyone. So let's start the session. I think there are power cuts and all that. So we'll try to start on time. So good evening to everyone. I'm Engineer Mustali Shahid, Chairman of IT and Computer Engineering Section Committee. So thank you for being here with us today. On behalf of IT and Computer Engineering Section Committee, I am pleased to welcome all of you today for our session, Transition Your Application from On-Prem to Public Cloud. It's a practical approach in the context of Sri Lanka. So this is going to be a part one. There will be 3 series of on this session. Part one will be the conceptual, information on the public cloud while you are transitioning to your application. Part two will be considering your practical approach, how you can practically transfer your on-prem applications to the public cloud. And the third session will contain, security concept of transitioning your application to public cloud on behalf of, on the context of data protection law. So without taking much of your time, I would like to introduce our guest lecturer today for this session. So Mr. Sanjeev Alvis is the first AWS certified solution architect in Sri Lanka and having experience over 2 decades in the cloud technology adaptation, on-prem to cloud migration, digital transformation, and software engineering. He is a technology evangelist and his experience is focused in managing various IT engineering teams in dynamic, mission critical, and global environments. So he is technically skilled across wide array of technologies of cloud architecture and design in leading to public cloud services such as platform as a services, infrastructure as a services, and software as a services. He also possesses a broad experience in Linux system, middleware, and database. He is a public cloud design architect, cloud management, automation engineering, cloud application monitoring solution, and content distribution network. So thank you for all to joining the session. Over to you, Mr. Sanjeev.
Thank you very much, Musali, for the introduction, and I hope you can hear me well.
Yes, Mr. Sanjeev, we can hear you well. Please go ahead.
Okay. Thank you for joining for our session today, and I'm trying to make it as much as interesting for you all, and also planning to have some Q&As at the end as well. So I have prepared some sort of a deck to start the proceedings. So let me share my presentation as well, so that it'll be easy for us to get the things started.
Yeah.
So
Mr. Sanjeev, you can full screen your slides. We can see your slides.
okay,
Yeah, that's fine.
that's better, no? Okay.
Yeah.
So as Musali explained, the topic is today transitioning your applications from on-prem to public cloud, and I'm trying to make it as much as relevant to Sri Lankan context. So a little bit of an intro of me. So I'm coming from a technical background and currently working as a director for one of the world's largest organization, and have extensive knowledge in the cloud domain. So without taking a lot of time, here are some of my contact details, just in case if somebody wants to have a dialogue, create a meaningful dialogue afterwards, probably we can get in touch. So without further ado, let me get into the meat of the presentation. So even though the presentation is today, or the session is about cloud migration, I'll take a couple of minutes, not more than 5-10 minutes, to explain what cloud is. and the basics around the cloud computing. So cloud is usually referred to a pool of compute resources that we can access over the internet. Now, for example, you all know data centers. Like, for example, we have our own data centers to host our applications, and we kind of host our applications on top of our data centers, and within that data centers, the servers, the network devices, storages, all that we purchase. Usually that's how data centers work. Unlike in US, in Sri Lanka, you don't have companies that provides data centers. Very rarely. I mean, we have, but very rarely we have a company where they provide a data center for us. Rather, what we do is for our company needs, for our institutional needs, we create our own data center with servers, networks, storage, and all that. So that is the on-prem data centers. That's we call on-prem or on-premises. But cloud is very contrast to that. Cloud is where we will have a pool of storage, compute resources, servers, networking devices, everything in a one common pool in somewhere in the world, and many organizations access that common set of pool of resources and use them to host their applications. So that is pretty much the difference in cloud. Now, in modern world, we experience a day-to-day life in many ways. The cloud computing, we experience the cloud computing. So I'll give you more details around it, but it is basically, somebody hosts a common set of compute resources that can be servers, memory, and storage, and networking. Somebody has its own set of compute resources, IT infrastructure resources, and many people access it and use for their day-to-day needs. So with cloud, so why then people would ask, why don't you have your own data centers? Why don't you have your own servers? Why are you going for cloud? Why are you going for something that is not entirely owned by you? Why are you relying on some third-party company to provide these resources for you? Rather, why don't you go and get it? So there are many benefits of using cloud, but cloud is, again, it's like the simple example where we always talk about. It's like the knife example where you can use the knife to do better things, as well as you can use the knife to harm somebody else. So that is similar to the cloud. It is again similar to the cloud as well. There are a lot of benefits that we can write, but again there are some disadvantages as well, which I will be discussing at the later stage. But with cloud, we will be able to access the most advanced technologies in the world. Now, let's say if we are to run our own data center in some sort of a building and having our own servers, it will be really difficult for us to keep up to date with what is happening in the industry, because industries are changing so fast. Technologies are coming really fast, and it is difficult for us to change. But when you are accessing a cloud platform that was offered by a large company, a multi-billion company, it is very easy for us to access the advanced technology because they adapt the technology. Most probably, in most cases, they are the one who invent the technology as well. So we can access most advanced technology rather than going on-prem, and it gives you agility and flexibility. Now imagine the time where we had this COVID pandemic, and there was a need to immediately come up with a software system to monitor people access. Now, let's say there was a need at that time. We couldn't do it in the way that we want in Sri Lanka, but many other countries did it. In Sri Lanka also, there was some progress there. but many other countries, they quickly adapt. They quickly developed a software system that gave us the ability to track people where they are. Now, for example, if I'm going to a shop, I scan my QR code, or based on my phone's location, there was a need for everybody to track where people went. So that was sudden request that came within within a couple of weeks. The requirement came in at the beginning of the COVID pandemic. Now, in such situations, if we are to going in the traditional approach, what is the traditional approach? Traditional approach is, now we have that to implement that software, we call tenders to purchase servers. And then, we evaluate 3 quotations and compare the lowest price, and we get the servers into our data center, and it will take some time to ship it. We make the payments, and LCs would open, all that happen, and then vendors come in, and we have to create, if our data center space is not enough, we have to expand the data center, we have to buy new racks, and we have to go through a whole lot of trouble to get a server into you to host that application. But with cloud, it is very easy. You just have to log into a cloud portal using internet, just like logging to a website. You can just log into a cloud portal and access the cloud platform. And with a click of a button, you can provision a server. And after that, either if you need 32 GB of memory and 16 GB of CPU, you can quickly spin up the server and have your application. So the cloud gives the agility and flexibility. This applies the other way around. Now, for example, let's say if the pandemic if let's say the requirement went gone down within couple of months, what if we took the traditional approach and purchased our servers? But then after 2 months, if the requirement is not there, our servers are left without, we cannot do anything about it. Now we have purchased the servers, but the servers are there. Now we don't have a way to get rid of that. But if it is cloud, you can again log into the system, and just with couple of clicks, you can decommission the environment. So this gives you the cost effectiveness. That means the pay as you go model. In cloud, it's pay as you go model. But in an on-prem world, where you have to make an investment. So there is something called Opex versus Capex. The finance teams and organizations always love to have Opex rather than Capex. Now, when you have a capital expenditure, when you make a capital expenditure, your cash flow goes down, right? You will, for example, let's say if you are buying one server, you will have to purchase upfront and then pay the entire amount to that server and then get the server down. But if you are using cloud, you have to only pay for that month's usage, or that day's usage, or that hour's usage. If you have used only for hour, you have to pay for only for hour. If you have used for month, then you have to pay for only for that month. So it's like, then the companies will have more cash to do other things rather than making huge investments initially, millions of investments initially. And also it is less maintenance. If it is in our data centers, we will have to take care of the power, we will have to take care of the air conditioning, we will have to take care of backup, and there are a lot of IT related activities that we need to do. And with this, some people are asking, even I remember 7 years back, one of my previous boss called, 7 years back this happened. One of my previous boss called me and asked, Sanjeev, what are you doing? So I said, these days, I said, I'm doing cloud. Then he was immediately asking me, are you doing cloud? So isn't it a job threat? Why are you doing cloud? This is like 8 years back, maybe. Yeah. So then I said, no, it is not a job threat. It will get, now I am not doing all these, mundane, repetitive activities which I did some time back. I'm not doing these things. But instead of doing that, I'm doing more cooler stuff. I'm doing more advanced stuff now. So it is not a job threat. So that is actually a misconception. So, and also, as I explained previously, it gives the performance, resiliency, and reliability as well. So I'm not taking a much longer time to explain why we need cloud. Now I'll explain a little bit about the cloud services models. Now there are 4 different models, and I'll explain 3 of them. That is, now in cloud world, there are some experiences where we have that we call SaaS. That means software as a service. Now you all have used Gmail. So Gmail is a good example of a SaaS. When you are using Gmail, you don't have to install anything in your laptop or in your desktop. You are directly through internet, through Chrome or through whatever the browser you use, you can directly log into the Gmail servers and use that application and access your email. That is called SaaS. They are providing software as a service. This is one of the models where cloud is delivered. That gives us software as a service model, where it gives the entire software. We don't have to do anything. We just can use that software. That's a one model. The other model is the infrastructure as a service. The infrastructure as a service model is in AWS, you can log into AWS and provision a server. You can provision your server. You can provision a large compute power with memory. And then you can install your own email server on top of that server, and you can create an email for your company. In that model, we are users of a IaaS model, infrastructure as a model, infrastructure as a service model. There, we only get the infrastructure. We only get the server. We only get the networking capability. We only get the load balancing capability. But having the software, installing on top of the servers and managing that software and creating an email server and giving email access to everybody is done by us. Unlike the Gmail example, we are not managing any Gmail servers, right? In Gmail, we are not managing any mail servers. But if we are to do something for our company, email, we can get only a server. So that is an infrastructure as a service. So there we are consumer of infrastructure as a service. Now there's another model, which is called PaaS. PaaS is in between infrastructure as a service and software as a service. In PaaS model, some of the platform related components can be taken. Some of the platform related components can be taken, and we can use them. You can use them for our usage. For example, now you may know about messaging queues. Messaging queues is something that needed for us to write a software. So we can go into a platform as a service provider. Even AWS provides that. We can go to a platform as a service platform, and then we can get the messaging queues. So there we can use that messaging queue and connect it to our own software and configure it. So that is a platform as a service. So we can use in all these different ways. We can use infrastructure as a service, or platform as a service, or software as a service. There are 3 different ways that we can use the cloud. So we need to determine what we can do. So here are some examples of PaaS and services, PaaS and SaaS services. Right, now the next one. What are the types of cloud compute? Now there are different types of cloud compute. When you are going out of on-prem to a cloud, this is something where you can look for and understand what I am going to do with my cloud computing strategy. What sort of a cloud computing strategy that I'm going to have? Public cloud, you know what public cloud is. I have explained it as well. like somebody is having their own cloud environment and multiple people going and accessing it. For example, AWS have their own data centers all over the world, and they provide compute resources like servers, networking, storage, everything. We go and access it. So Amazon, Azure, Oracle Cloud, Google Cloud Compute, GCP. So these type of cloud providers are the public cloud providers that we can access and create our servers, create our own, cloud resources in that cloud services. And there's another type, which is private cloud. Private cloud services are where even you can transform your traditional data center to a private cloud. So you can have private cloud platforms. It can provide through HP or through VMware or through Oracle. You can transform your data center to a private cloud and create an environment where somebody can come and click a button and provision a virtual server on top of your private cloud server. So there we will create a virtual layer on top of your data center, and we can use that virtual layer to provision compute services or storages, and we can use it. And there's another way, which is the hybrid cloud, where in some cases we want to have public cloud and private cloud combined together. Now, there are some government regulations are there. Some data we cannot store outside of the country. We have to keep that data within the country. So in that case, we can have that databases within our private cloud, within our data centers, within on-prem, and connect that to a public cloud service. Your applications may run on public cloud services like Amazon, Google, and it is connected to the data which is in the private cloud. That is kind of a hybrid cloud model. That is again an approach that we can take. The last approach is multi-cloud. Many large enterprises are actually doing multi-cloud because they don't want to rely on one provider like Amazon or Oracle Cloud. They don't want to rely on one. They want to be as much as vendor neutral. Now, when you are using these public cloud services like AWS, now if you start using their services, sometimes it will be really hard for us to get out of it. We may be, we call it vendor lock. We may be vendor locked into that. Let's say now if I write an application to use SQS, which is the Amazon's queen system. So Amazon's queues, simple queen system. So if you use that, if you use AWS APIs, and if you write our software code accordingly, we will be depending on AWS services. It will be hard for us to get out of the AWS. We will have to do a code rewrite again to get out of AWS. So instead of that, we can have different mechanism where we will not use the PaaS services on AWS, but we will use only the infrastructure as a service, like basic compute storage and basic compute storage and memory, but we will not use their PaaS services. In that way, we will not be vendor locked. So in a multi-cloud environment, you can have some components running in AWS and some components running in Google Cloud. But at any point, if we decide, let's say, there's something big happening and the AWS data centers all got impacted by some sort of something that and then they have the immediate ability to move the workload from the Amazon to Google Cloud because they have not vendor lock. So there are strategies that we have to think before migrating into cloud. So all of these background knowledge is very much needed instead of just moving to cloud. So sometimes maybe people may feel because this is the trend, everybody goes to cloud. This is how we are going to go to cloud. That is not the way we should take. We should take it. We should have a proper approach and understand all the aspects that can impact us. So to do a cloud migration strategy, what are the main things that we need to have? The main thing is, first we need to have the migration methodology. This migration methodology includes identifying what applications that we are going to migrate to cloud, and what applications we are going to keep, and how we are going to migrate, and what is our migration strategy, methodology. Are we going to go for a multi-cloud, or are we relying on Amazon? Mind you, there are large companies in the world that makes billions have only relied on Amazon. They have only relied on Amazon. They have taken that risk because they have the confidence. That is also there. On the other hand, they haven't gone for Google Cloud and multi-cloud environment. They are solely on Amazon or solely on Azure. That is also happening in the world. So this cloud business is trillions in the world. It's, it's trillions, and it creates a lot of generates a lot of revenue as well. So sometimes in these type of situations, we need to get out of the island mentality as well. Sometimes if we don't have the exposure to the large entities, then we might think like, we call it, we see the crocodile in the teacup. Sometimes we may tend to think like that as well when it comes to cloud technology. We may look at it suspiciously, but large enterprises in the world, Fortune 500 companies, have taken a drastic approach in adopting cloud. I don't think any large successful entities are now running on a traditional on-prem type of world. They all have migrated to a cloud providers, or have their own clouds. So we have to create that migration methodology. We need to identify what is the scope. The methodology includes all of that. I'll explain it a little later in detail. Explaining it a little later. I'm moving to the next one, which is the cloud and partner tools. Now, when we want to migrate, the next thing we need to finalize is what is the cloud that we are going to migrate, and what are the partner tools that we can do. There are so many tools that helps migration. We need to finalize what is best for our workload. And then the next aspect is we need to work with a cloud partner. If you are an enterprise, if you are a large company, you need to, it is not just like switching one server to a cloud. You may have to create the architecture. So for that one, you need a cloud partner, someone who's experienced in cloud, someone who has done migrations before, someone who has, have in-depth understanding. So that relationship you need to create. So sometimes we may need the cloud professional services as well. That is, for example, if you are going to AWS, we might have to get the AWS support as well. Or we might have to get the Azure support as well if you are going to Azure. So that is also we need to finalize. And the next aspect is we need to have cloud training. Whoever the engineers that are involving in this migration, they all need to have training. This can be done through the partners as well, cloud partners as well. Now, for example, we have worked with many companies, and we have helped manage large state. Now, I personally have the experience of managing more than $50 million worth cloud state for one of the largest education entities in the world. So it's the cloud budget. The budget for the cloud, that company is paying $50 million annually, 55 this year actually. Last year it was 50, and this year it is $55 million to Amazon. So the stake is huge. Some of the T2, sometimes the T2 instances are like 10,000. So there's a huge there are many people in Sri Lanka who has exposure and experience in working in such a large cloud environment. So from them, I think the cloud training has to happen. And also the next important thing is the cloud investment, which is something we are very carefully have to plan. Because if the investment plan is not proper, sometimes If you don't do it right, it will end up in costing more than data centers. Because when cloud is accessing unlimited bottomless resources, right? Any engineer, if you are not putting proper mechanism, any engineer can go and provision a new server. When there is a performance issue of your application, if application is not accessing enough, then if application is having performance issues, instead of fixing the code, if it is in cloud, we may tend to provision a new server because we are paying it later. No? Unlike purchasing servers, here it's like we have put the credit card, the payment goes later. It's just the provisioning a new server. It's just a click of a button. So the exponentially the cost will keep up, and it will create a more damage. But this is some, if you are not plan it well. But if you plan it well, this will save huge amount of money for the company. So the cloud investment planning, cost analysis is also a very important thing, because there have been more than 60 times the cloud prices have went down. Now that is, if you know the economic concept called economies of scale. If economies of scale is now, let's say, if we are building a shoe, if I'm a shoemaker and if I'm making a shoe, and if I can make only one shoe per day using my hands, I might have to sell it for at least 5,000 for me to live for that day, right? I might have to say whether customer buy it or not, I have to price it at least 5,000 or 4,000 for me to spend my day. But let's say if I have machines where I can create more shoes, then my cost will go down. My rent will distribute it across 1,000 shoes that I created. My lunch cost will distribute, because I am getting, even I make 1,000 using a machine, I will still have the one lunch. So my lunch cost will distribute among the 1,000 shoes. So the cost will reduce. So more and more people get into the cloud cost goes down. This happened all over the world. Now cloud is very cheap. Now cloud is very cheap where compared to having your own thing, because someone can argue during these times where you don't have much dollars. Why should we pay to external countries, and why should we put our money out? But again, that is a good argument for cloud as well, because in cloud, you are paying only the things that you use. But if you are using on-prem, you have to purchase servers and upfront, and you have to pay huge amounts in the beginning. So that is something where we can think of. So moving to cloud is a better option considering the situation of the country as well. So then the next one, what is the cloud migration methodology? How can we do it? So first we need to evaluate why. Why are we going to cloud? That is the first question we need to ask. And we need to have a proper business justification to do that. Do we want to experience most modern technologies? Do we want to reduce the cost? Or do we want to simplify our state? Do we want to minimize the risk? Because let's say if you have only one server and you don't have a backup proper mechanism created, then it is really difficult. Now because you have to invest another same amount of money to create a whole data center in somewhere. But in Amazon, that is already given, right? That is already given. Now imagine Amazon has something concept called region. Region means within the world, there are different regions. In Singapore is a region. In Singapore, there's that is called region. In that region, and also US East is a region. The East Coast of US is a region. In that region, you will have availability zones. That means you will have data centers in many areas that is divided into availability zones. So if maximum that can happen is one day availability zone can go down, and all the other availability zones will be there. So nothing will happen to your data. Nothing will happen to your service. Your service will continue to operate like this. But let's say if you are to do the same thing, you have to have one data center in Colombo, another data center in Hambantota or Jaffna, somewhere else. Then you have to create that internal architecture. To provision one server, you have to purchase two servers, one for your server and one for the backup. But in cloud, if you are purchasing one server, you are just purchasing one server. But that one server will have the ability to fall back to another server if this goes down immediately, without even feeling. Without milliseconds, microseconds, it can switch. So you need to understand that. So evaluate why. And then next is very important. What is moving and how is moving? I will explain that later as well. And then the next step is migrate the applications and the data. And then, how we modernize. So I will explain this. So there are 6, we call it 6R approach in migrating to cloud. So 6R approach is retain, retire, rehost, replatform, repurchase, refactor. There are some workloads, some applications we cannot move to cloud. Let's say if you have a complex architecture, and in a complex architecture, there can be some old applications, which is really hard for you to move to cloud. Let's say, you are within next year, you are planning to retire it. So why do you spend all your money and effort in moving it to cloud? You rather wait for 1 year and make it retire. So there are some applications we have to classify in our application domain, what are the ones that we are going to retain. So that is a retain approach. And there can be some components in our application that we may want to retire. During the migration, we will realize there are some areas where we don't need to migrate because we can use it with we can have a different thing to do the same thing. So we can retire it. And the next 3 ones are the important ones. That is the rehost, replatform, and repurchase. So rehost is, we call it lift and shift. That means whatever you have on-prem, we take it out and put it in AWS or put it in Google Cloud, put it in Azure. We can take that lift and shift. This is called rehost. So in this rehost approach, so we can identify which applications we are going to rehost. So during this rehost applications, identifying this process, we can consider a couple of things, because rehosting may not give you sometimes it may not give you the benefits that cloud can offer you. Because in data centers, your applications have designed in a one way, but in cloud, you can design it in a much better, efficient ways, much better ways that can make the application faster, or applications cost lesser. There are much productive ways that can do. And also your on-prem application might have designed 10 years back. The technologies that was there in 10 years back might be outdated now, but we might have a better alternative technologies in modern day. But you will not be able to get the use of that technology if you do rehost. But there are certain stages where we need to rehost, because sometimes there was a very recently we involved in a migration. The databases were like in terabytes, 10 terabytes, 15 terabytes. It's huge databases, and the application architecture was completely monolithic. Like, one big software code, not like a microservices distributed architecture. It's a huge thing, but we had to start from somewhere. So what we did was, the first step was we took everything from the data center and put it to the cloud. That was our first step. Now our next steps will be, breaking that application into smaller pieces and retiring some of the databases will get smaller with our process. So we'll do the changes later, but immediately we'll get out of that. That again, we'll have to consider based on the need of your organization. Now, for example, let's say in your data center, do you have all servers that can go wrong, that can go down within like very few days. You might have servers that are end of life, right? So in that case, you cannot wait and rewrite the application according to the cloud technologies. You cannot wait. You have to somehow get out of the data center. So you have to immediately get them out and put it to the cloud and do the changes in the cloud. So that is rehosting. So the re-platform is a different thing. Now re-platform means it changed. It can be OS version, database versions are changing. Now, for example, you might have there is in our AWS we have something called RDS, relational database service. So relational database services where you will not need to administer the database. We will just have a login to the database. Now in on-prem, we will have to manage the server. We will have to manage the cluster. Let's say it is Oracle. If in on-prem, we will have to manage the cluster, Oracle rack. We have to manage the server, and then we have to manage the rack, Oracle rack. And then we will have to manage the databases as well. But if it is on RDS, you just have to manage the database only. Managing clusters, managing servers is not your responsibility. AWS is doing that job for you. You just have to log into the database and create your tables and use it for application. So moving from managing your database in data center and shifting it to RDS, we call it re-platform. And moving from your OS versions to a better OS, updated OS versions in Amazon or Azure, we call it re-platform. So re-platform is also needed in many cases. The fifth one is called repurchase. So there are some legacy things that we might have purchased some time back, and they might be running on our data centers. Maybe old payment gateway, which is now retired in the world. I mean, they also have moved to new versions, but still we are using it. Old payment gateway that is rusting, and maybe an old message queue. There are tools, third-party software tools. We have purchased old API gateway. So there are many third-party tools that we have purchased and installed in our data centers, where now we don't. Now there's no newer version of that. We have to retire them. So in that case, we can repurchase. We can repurchase all these legacy ones, and we can get the new one. So the final one is the refactor. Refactor involves the complete code overhaul. As I told you in my previous example, where some applications are large, huge monolithic applications. The one code base itself, one repository, the one code base itself has all the features. There is no microservices based distributed architecture. And that code to run, we might need at least 32 GB memory to run that large code base. Even more, there are so many memory leaks. So these type of applications, we want to refactor them. We want to get them and we want to write a new code according to the cloud services. It is completely an overhaul, completely a change of the technology architecture. That is also a good option in some cases. In some cases, that is a good option for us to follow. So this is the 6R approach. Now, you have to sit down in a whiteboard and identify with your cloud partners, with your specialists, what is your current application nature, and how long you're going to have that application. You have to consider all these aspects and how much will it cost. Considering all these factors, you need to identify which component of your application has to be retained, which component has to be refactored, which component has to be retired. That the big picture, you have to draw it first before making any cloud migration. That migration strategy may change over time as well. Over time, that may change, but you need to have the plan. Then only you will realize where you are going towards. So this is so this is again more detailed explanation of the previous one. Now let's say first step, as I told you, it is the discover, assess and prioritize application. That is the first step. Now from that step, you determine the migration path. After you analyze what is the state you have on your data center on-prem, now next step is what is your migration path. If your migration path is rehost, that is lift and shift, then one approach that you can take is you can automate the cloud infrastructure and migrate this, do this migration automatically. This is very beneficial based on your technology. This is beneficial because in this model, you can have a one automation and use it for dev, QA and production environments using the one automation, because you will run a one script to provision the services in AWS. So that script can be written in, let's say, CloudFormation or Amazon AWS CDK or in Azure automation. So however the mechanism, you can create that automation, and that script will provision the environment. Now in cloud, if let's say in Amazon, if you use CloudFormation, you can create all the services with just a click of a button. You can create the virtual private cloud, which is the network your services will run on. You can create that network, you can create the subnets, and you can provision the database servers, and you can provision the web services, and you can provision the middleware services. You can provision all of that using a script. So this is called infrastructure as a code. Your infrastructure, we take it to a code file, like an XML file or a JSON file. We take it to a file. And with that file, when you execute it, in cloud, all these servers are automatically provisioned. The entire architecture is created, just like provisioning a virtual data center in somewhere in the world. So that you can do. The good thing is, if you do in this way, then you don't have to do it for multiple times. Production, staging, the development environments, all things you have to only create once. The automation you have to only create once. Then you have to just replicate in the other times. But in some cases, you may have to go and manual path and manual installation, because if your application is old and there are certain things where we have to go for the manual path. In that is also something where we have to decide whether I'm going for the automation path, whether I'm doing the migration automatically, or whether I'm going for manual approach. This is the rehost approach. Now the next one is the replatform approach. Replatform approach is, we need to first determine what is the new platform. And we need to modify the underlying architecture according to the new platform. And then use the migrations tools. There are so many migration tools that we can use based on your need. And it is case by case thing. Based on your need only, we can determine which tool that is best for your thing, because it will take for about 1 hour for me to explain all the migration tools. But that is something where you can learn. Maybe I will share some details of migration tools for different cloud providers at the end of the session. So you will understand what are the migration tools. So this is the replatform path. And the next one is repurchase. So that is again very straightforward, where you can purchase the SaaS licenses of the new product, and you can manually install it and set up. And even in there also you can do automation if it is required. The next one, which is very complicated, which is the re-architect or refactor. Refactor. Here we have to redesign the application and redesign the infrastructure architecture. Once you redesign your application, redesign the application architecture, then you can do the app code development. And here you have to go through the full software development life cycle, where you have to have the dev environment, QA environments, and then install the code, the traditional CI/CD pipeline. You start from the software repository, and You have the new software repository created for your new application, and the new architecture, the application will be developed with the engineers, and we will have a dev environment for us to test. And from that software repository and the dev environment, there will be back and forth. The code will move back and forth, and it will merge into the main branch. And then from there, the continuous integration starts happening. The continuous build will happen, and automatically it will develop into a staging environment. And then in that staging environment, we can do the testing again, and then we can put it to the performance environment to do the performance testing in cloud. And then we can finally put it to the production environment. So it is the full life cycle of a software development will be come into play here. And this is again a conscious decision, business decision that we need to take, whether my application has to be redesigned. Now, let's say if I don't see my application is running after next 2 to 3 years, why should I waste my money and effort and company's resources to re-architect? We should not re-architect. We can just re-host it and get through these 2 years and retire that application. We can go through the rehost part, and we can, if it is like 3 to 5 years, if the application run, we can go for re-platform. But if you are here for the longer run, if your application you want to run it for the next 10 years, you see that there's a business for this application, then you can do the re-architecture. With the re-architecture, a lot of technical debt can be minimized. An application will take a new phase, right? So this is the another part. So we have to carefully design based on your application which path you want to take. So this is again a complex diagram. I'm not going to explain this. So this gives the viewpoint in a migration project. The sprints, sprint 1, sprint 2 are the sprints. That means the time frames that we are doing this migration. And sometimes this sprint may be 1 week, and sometimes this sprint may be 2 weeks. So within first sprint, what are we going to do? Within second sprint, what are we going to do? Within third sprint, what are we going to do? Likewise, this is a breakdown of activities. Now here, there are so many aspects we need to consider. The one aspect is, we need to understand the existing AWS or the Azure or the data center architectures. That is where the landing zone is. And then we need to understand the operating model. What will be our operating model with the new cloud environment? And how do we manage compliance and security? And what are the aspects that we are going to implement for the security? And what are the applications application portfolio? What are the applications that we have? So how do we identify our application portfolio? That means what sort of applications that we are going to do, and what are the data that we are going to do? So for example, the application portfolio discovery and planning stage. So what we have to do is we have to identify the application portfolio data for migration. So in first sprint, we can do portfolio data collection and analysis. And in sprint 2 and 3, we can come up with a scoring model defined and validated. How do we do that? So it is like a complete, robust, detailed way of migrating. So this is I just put this here for your reference, so that you will understand how complex a migration is. But trust me, that is worth it. That migration will give you exposure to new technology, and if you do it right, there will be no hiccups, there will be no downtimes, there will be no cost, additional cost. Engineers will be happy because they will expose to the new technology. People will update themselves, and applications will run faster, applications will run better. So it is a worth investment. And to do that, there has to be a proper planning. So this is like a blueprint where you may not need to follow all the steps listed here as well. So that is where you will need an expert help to get that and understand it and move forward. So finally, what are the challenges that we will have in AWS? in AWS, managing cost is a challenge because it is like giving the key to the kingdom. So, you will go and enjoy the kingdom without any boundaries. You will provision the servers as much as you like. Even for a small application issue, you may go and provision another server and create another cost to the company. So this has to be managed properly. And sometimes the complexity. The cloud is very complex. Sometimes it gets complex because if you are not designing a proper architecture, if you don't have a proper architecture, and if you are not using the simple tools available, then it can create complexities. And also the other challenge is dependencies. Sometimes when we are moving an application, there are some other dependent applications that they cannot move to cloud. So your application is moved to cloud, and that application itself is running fast, running smoothly, everything is happening there. But when that application makes a call to a dependent application in a data center, if that is slow, your entire effort is worthless, because ultimately the customer doesn't feel the speed in his business transaction. He feels slowness because there's one component residing in data center that creates the slowness for the entire business transaction, entire customer journey. So those dependencies has to be identified and has to be managed well. And there are legacy applications which is really difficult sometimes to migrate. So that is also we need to think about. And then migrating database is a humongous challenge. There are tools, even Oracle has tools that they have introduced to migrate databases. So we have to use those proper tools in migrating. And the most important other aspect is the stakeholder support. So you'll be working with multiple stakeholders as an IT. So how do you get the support of your stakeholders? How do you convince them? Is again something challenge. And the last one is building cloud fluency. Now this is actually has become good now in Sri Lanka. If you look at it, there are hundreds of cloud professionals. When I started cloud in Sri Lanka, pretty much I was only, and then we kind of created a team, close to 40-50 people work with us very closely. And now in many companies, in everywhere, people are doing cloud, and there's a lot of exposure in cloud and a lot of experience. There are engineers who are in Sri Lanka, have worked in multinational companies and have managed very complex cloud migration projects. So cloud fluency is now there. But in traditional organizations, sometimes, sometimes in some organizations, there might be people might be reluctant to move to cloud. That I understand, because every time a new concept, new thing comes up, we may look at it differently, because what we have been doing is comfortable for us. But I think we need to get out of that comfortable zone. You may have your reservations for public cloud, but that doesn't mean you should not implement a private cloud. So there may be reservations to move to new technology. A fear saying, will I be able to learn this technology? Will I lose my popularity that I had before? Will I lose my technical capability that I had before if I move to cloud? There are some mental barriers like that as well. I think those are very easy to solve, because when you get into cloud, you will realize, if you are really good in data centers, if you know how data center works, cloud is nothing. Cloud is nothing. If you understand how the data center works, if you understand how the networking works, if you know how a WAF is provisioned and how a load balancer is there in your data center, what is your IDS, what is your IPS, and how the load comes into the servers, and what is your subnet that you have put the web servers, and what subnet you have created for your backend servers, and how do you get the internet connection. If you know in and out of your data center, you will learn very easily the cloud. The modern generation, the generation who have passed out from universities within last 2 to 3 years, they have exposed directly to cloud. They call themselves native cloud technologists. So they have directly come and land in data center, land in cloud. Now I remember Even though I, with an engineering degree, even with a degree I passed out, when I started, I was given, the first task I was given is to, lift the servers and put into the racks. So that was the job that we got those days. But now, the new generation comes directly to the cloud. So sometimes I may feel that they are missing some exposure to data center. So, if you are a new graduate who passed out just recently, try to get that data center exposure as well, because that will make you very easy to understand the cloud technology. Then you will know, because in your mind, the picture is drawn in your mind from the wires, from the network cables itself. You can see what is happening, how it is happening in cloud. So, so that is something where I can explain. And this is not a technical migration demo session that we can have. I think Musali will arrange in future. But one thing is, the demo part will again cover only one aspect, because there are so many different strategies, so many different migration tools. For Amazon itself, there are more than 10 to 15 migration tools. And for databases also, there are many multiple migration tools. And the tool that we use to do data migration may be not the same tool we want to do for the application migration. So, it is very complex. But, maybe we can do a small demo in future on some areas, selected areas, to show how this can be done. And in Sri Lankan context, I think we have large banks in Sri Lanka, where there are core banking systems, and some of the systems has to run within the country. And there are large telecom providers in Sri Lanka, where some of their data has to be reside within the country. But again, there are many opportunities even within that complex architectures to move some of them into cloud, and even use the public cloud as a temporary destination, while you use your existing infrastructure to create a private cloud. Because in modern day, agility is very important. As with my previous example on the COVID, the requirements comes like this and goes like this. So we have to build the application, launch it, provide to the customers, and retire within very quick time period. And then that requirement is gone. And if you are late, you will not make any money out of it. If you are fast, within that specific time frame, you will make money and you will go. Now imagine if somebody can come up with immediately a software to a public app for people to mark which fuel station has gas now, or which fuel station has fuel now. Let's say I know for sure thousands of people will quickly install it, and they will mark when they see when a fuel for a fuel station, when a new browser unloaded their when they see it, they will immediately mark in the app, okay, this fuel station has now fuel, right? Then our people who are around can go and get it. But this is, and that app will have, I think, max 10,000 downloads for sure. And this requirement will last for about maybe 6 months, hopefully 3 months. But within that 3 months, 6 months, people can make some money by selling some advertisement. But if you are on-prem, can you react to these requirements fast? No, because you have to purchase the servers for this application to run, and the service has to come. And if you have already purchased servers that are unused, that means you have wasted company's money, that you have already servers that are in your data centers that have not been used. So then you might ask, how come Amazon makes money? Because they get so much servers, and they have so many idle servers in their lot. And but they, that's how when we provision a new server, they have a server. Yeah, they have a proper, very neatly planned mechanism for that. For them, adding a new rack into their data center is again a click of a button, because they have automated everything. They have most modern technology. They just get the rack from the manufactured directly and place it in the data center and quickly plug the cables, and the storage, compute power, everything is added to their data center quickly, because automations start quickly, kicking off. So they can do it faster than we do. And also they have their spare compute resources. Let's say now they have spare resources, spare compute power. They use that spare compute service power and create another service. Serverless is a great example. Serverless is you don't get a server. You will just have to upload your code into cloud and that code will run. Where that code is running, you really don't want to know. It can be a spare cycle in someone's server, or it can be somewhere, it can be a spare cycle in a CPU cycle in their own servers. Wherever it runs, no matter what it is, it will give you the results. We really don't want to bother where it is running. So they have different models of selling these unused compute power, unused storage, unused memory. But we can't do it within the on-prem because our scale is small. The same example, shoe example, where economies of scale. So I think that is all from my end. So I can take questions if there are any. And I see a question in the chat. It says, what are the industry accepted guidelines, standards available for organizations to follow when moving to public cloud, especially on how to secure the infrastructure and vital data? Yes, there are various frameworks that have been developed in cloud that we have to consider the variables in the platform. For example, what sort of a data you have? Does it involve PII data? And if the PII data is involved, then the approach should be different. And what is the it is all about security and availability, and the cost is like, balancing, juggling with 3 balls. You have seen in circus, people are juggling with 3 balls, right? If you hold on to 1 ball longer, you will lose the other 2 balls. So it's similarly, security, cost, and availability are like 3 balls. So we have to identify exactly what is the perfect balance of these 3. Sometimes to achieve higher security, you might have to pay a lot of money, which is again not worth it compared to the revenue that we can get out of the application. So this is where, if somebody is doing this exercise, need to understand all the aspects of an application before making decision. How long this application will run, how much money will it generate, and what is the nature of this application, what level of a security is required for this application. You have to list down all these aspects and implement. So the industry accepted guidelines is usually, especially for the security and security for the data, in AWS, let's say an example, there's a shared responsibility model. It's called shared responsibility model. There are some aspects where AWS takes care of the security by themselves. There are certain components, certain part where we have to take care of the security. So we don't have to worry about what AWS is providing, because their platforms are very much secure, and there hasn't been breaches for years. I mean, there are here and there we hear some cases, but it's very safe because they have made huge investments. I would say, rather than it's safe, it is something where we can. It is something where we can. Give me 1 minute. I'm getting some sort of an issue with my connection.
We can hear you, Mr. Sanjeev.
Okay, cool.
We can hear you. So I have a question, Mr. Sanjeev.
Okay.
Now, when it comes to SLA uptime of the systems, what is the guarantee that the cloud providers are giving? We recently came across, I don't know the reason for that, WhatsApp was down for a couple of hours, even the Facebook also down. So they were running, as I remember, it's on the cloud. So basically SLA, service level uptime. What is the service level uptime in the cloud infrastructure? I mean, based on your experience, more than a decade, you are running your systems on the cloud, the leading educational system. So what is your thought on that?
I think it is very safe, because it is again a comparing game, because now the amount of money we can spend to achieve the nines of our availability. Now let's say to achieve 9.99.9, if the cost is $1, just an example, if it is to achieve 99.99999 availability, it would cost us 100,000. It goes exponentially. So we have to always compare what is the availability and SLA we can get from our investments, our on-prem. So in all the cases, I can very confidently, in all the cases, the SLA that is given from the cloud providers are very much higher than what we can achieve in our data centers. Because our data centers, because of the scale is more, nothing because of technology or anything, nothing because of our people's inabilities, because of the scale is more. Now, we cannot have one data center in Colombo, another one in Kandy, another one in Hambantota to create the high availability. But Amazon has done that investment, because their investment is again distributed across multiple users. There are thousands of customers that they have. Because of that, they can make that huge investment. Now, in their one availability zone, they have about 6 to 7 data centers spread in many areas. If a lightning struck or a earthquake happened to one data center, there's another data center where quickly, the workload is simultaneously running. So they have they have satellite links, and they have underlying internet links. So there are so many different investments that they have done. So I think those investments are huge, and these are, I mean, we cannot even pay attention to that. So, but again,
what about their RPO and RTO, recovery time objective and recovery point objective, in terms of multiple zones?
So that is again, as I said before, defined by our architecture as well. Now, I mean, even within the cloud, we can achieve higher levels of RTO and RPO, making little bit more investment, or making a little bit more. Now, for example, let's say if a disaster struck, and if we have purchased one server in one availability server, and then if a disaster struck, or if something happens to that application, it will go away. But if we have provisioned 2 servers and load balanced within the 2 different availability zones, then we will not feel anything. So it is about us making the investment. Now, let's say again, it is again not a huge investment. We can have the secondary server in a cold mode. There are different various ways of doing that. So the time to start provision, your time to have your service back up and running is very minimal if you architect it well. But let's say if you put all 3 servers in one availability zone, you might have 100% downtime, and you will take a long time even on top of the cloud to recover it. But if you have architected well in multiple zones, again it's that. So it's achievable. So cloud gives you give you a higher number of SLAs, but it is us when we are implementing in cloud to use that in proper way. Now, they say S3, I can't remember the exact number, but they say is in every 10,000 years, there's only possibility of, losing one object in S3 bucket. Losing one object from after only 10,000 years, only one object will lose. That's what their mechanism is, and they have proven it. And these are not like some random guy and coming and telling. These are complex mathematical algorithms defined in one of the world's leading universities with mathematicians and probability statisticians, and they have calculated it. I mean, otherwise you will get sued, and this is not just a marketing gimmicks that sometimes in some advertisement we see. Because if these SLAs, in some cases the Amazon is entering into agreements with the large enterprises, sometimes large financial institutes. So if one transaction goes down, that will cost billions. So they have to provide this, otherwise they will not sustain in this business for more than a decade. So but again, it is a shared responsibility model. There is a part for us to play, and there is a part for them to play. So they, and if somebody can come and give an example and tell, look, in Amazon in 2019 or 2021, the S3, there was an issue in S3, it took 20 minutes to up the S3. Yeah, there are one or two examples that we can someone can point out, because in this world there is no perfect 100% perfect solution. It is in our data centers also, it is not there. So if we cannot achieve it in our data centers for 100% availability, then you really cannot do it elsewhere. But when you compare it to the investments that we can make versus the investments that they have made, they have invested a lot in availability, so they are much faster or much available.
Thank you, Mr. Sanjeev. So any questions from the audience? Please type on the chat box. Any further question? Okay, thank you. Engineer Achini, over to you.
Good evening, everyone. It's with great pleasure that I'm delivering the vote of thanks. Firstly, on behalf of IT and Computer Engineering Sectional Committee, we wish to express our sincere gratitude to IESL President, Secretary, and staff. On behalf of the Organizing Committee, I would like to extend a special thanks to Mr. Sanjeev Alvis, who has given his precious time to conduct this event. And we are thankful to him for sharing his immense knowledge on cloud technology with the engineering community. Once again, many thanks to enable this evening to have a successful event. Also, I'll take this opportunity to thank our organizing team of IT and Computer Engineering Sectional Committee for helping us to arrange this public lecture. We are organizing this kind of events to uplift IESL in all aspects. Finally, I extend my big thanks to all the participants who make this event successful. Thank you, everyone. Have a pleasant day and stay safe.
Thank you, Engineer Achini. Thank you, Sanjeev, Mr. Sanjeev.
Thank you.
Thank you. Good night.